Now, for those observant amongst you who've noticed that I'm not Steve, you may have also noticed that I've got a very weird contraption on my shirt here. I'm wearing an apron because, well, bit of a fun fact, I love baking. And I thought, what better excuse to come and teach you guys some of the science behind cooking and baking than Easter. Because I know for me, Easter is very special because of the amount of sugar we get to consume. And if we're going to do it, well, we might as well be scientific about it. So I thought today we'd explore the science behind a couple of very, very common Easter sweet treats. And if any of them survive the weekend without being consumed, well, you can try doing some experiments with them yourself. But even better, if you do somehow manage to consume all of the sweet treats you find around the house this weekend, let me teach you how to make more. One of my favorite Easter treats, marshmallows. These beautiful squidgy clouds of deliciousness that are actually just sugary bags of gas. Now, I'm going to give you guys a second to think about what gas do you think is inside our marshmallows? Hopefully it's not farts. Dad's not been anywhere near the marshmallows in the pantry. No. What other gas could it be? You got it. Air. Right? That beautiful combination of gases in the space around us, air, is actually 50% of the volume of our marshmallows. So if we're going to make some, we're going to need a way of introducing a whole bunch of that air. And today, to help us do that, I brought along a whisk, right? As well as my apron, guys. You will notice that when I show you our bench today, I have changed a few things in our lab to make it food safe. I've thoroughly cleaned everything. I've got a tablecloth down, and I'm using equipment we do not use for chemicals. I also very thoroughly washed my hands just before we came on air, and I will sanitize again before I get started. So guys, whenever you are cooking or doing anything with food that you may be consuming, make sure that you are clean, safe, and hygienic. So we've got our whisk, which is nice and clean, to help us introduce air into our marshmallow. But if I just turn this on and start whisking the air around me, it's not going to do much. Just agitate those particles of oxygen, carbon dioxide, nitrogen, and everything else around us. So we need a way to capture that air. Originally, marshmallow was made from a plant called, well, you guessed it, the marshmallow plant, right? The marshmallow plant had these amazing squishy aerated roots full of this organic compound that made a sort of jelly-like texture. And the ancient Egyptians were actually the first to chop up this marshmallow root and roast it in honey to make it a nice sweet treat. Some people even use marshmallows as a remedy for sore throats. But we don't use marshmallow root anymore to make real marshmallows. Nowadays, we use gelatin. Now, for the recipe I'm going to show you guys today, it's important we use gelatin powder. This stuff you can just get from the supermarket, guys, so go check out the baking aisle. Last I checked, there was still some in stock. Now, gelatin is not made from animals' hooves. Important fact. Most gelatin that we use is actually from the skin of pigs. 30% of pig skin contains something called collagen, which is a protein that allows skin to be nice and flexible and supple. It's also really important to keep our skin nice and flexible and wrinkle-free. Gelatin is one of the proteins in collagen, and when you wet it, it absorbs that moisture. When you heat it up, all of that protein unravels, and all those long strands, those polymers get tangled up. They don't bond together like things like egg whites do. Instead, as they're tangled, they form a nice slippery gel. And that gel forms the foundation that's going to trap the air to make our marshmallows. Enough talking, more doing? Let me show you how we do it. I'm going to bring you down to our bench. And guys, don't worry if you don't catch all of the details today about how to make our marshmallows. We will be publishing the recipe online once we upload this video to the Learning Lab later today. So over the weekend, check out the Learning Lab for our recipe to make your own marshmallows. Because think about it. A recipe is just a scientific procedure that we normally do in the kitchen. Now, to do our marshmallows, we need our gelatin powder. We need our teaspoon to measure it. We're going to need some cold water and some hot water. I've got a kettle that I've boiled, and I'll get my producer Brian to grab me some cold water in a jug as well. As well as that, we have one of the most important ingredients of marshmallows, white sugar. Now, caster sugar works really well here, but if you don't have it, you can just use white sugar as well. Okay, first things first, we need to prepare our gelatin. I've got a small bowl to help me do it. Our recipe today says that I need 2 teaspoons of gelatin. Thank you, Brian. Just pop it on the bench for me. Proper measurement technique. I'm using a clean knife to wipe off the excess and putting my 2 teaspoons of gelatin into my small bowl. Now I have this funny granular gelatin. Doesn't look like much, and I certainly wouldn't taste it. It's a very, very mild flavored protein, one of the only proteins we use as thickening agents. If you wanted to make a vegan version, you could try using agar-agar, which comes from algae instead. But today we are using our gelatin, and we're going to add 1/4 cup of hot water into that. Then I'm going to give it a little stir. Now, anyone who's worked with gelatin before might be worried, right? Because we always dissolve gelatin in cold water so it doesn't get lumpy. This recipe we're using today, guys, is what I call Cheats marshmallows, and it is the simplest, easiest way to make them. So we do take a few shortcuts, which does mean it's easy for kids to do over the holidays and help out. Because we do tend to get a little bit of lumping with our gelatin, I'm actually going to use my whisk to really mix it up. And get those lumps out. I'm going to leave that off to the side. It's a little bit bubbly, but we're introducing air today, so that's what's important. Next step of my procedure tells me to combine, right, my sugar and my cold water. My measurement today is that I need 1/4 cup of sugar. Now, guys, you can halve this recipe, double it. It's entirely up to you. I find this is plenty to make enough marshmallows for the family for the week. But if you're more of a sweet tooth than me, you might like a little more. And, oh, I forgot to double my sugar. I actually need 3/4 cup sugar. So 3 of those. You see why I've halved my recipe. And 1/4 cup of water. Just cold water here. In it goes. Now, I whisk. Now, this is where caster sugar can be better than our regular sugar because caster sugar is much finer and it dissolves a lot more easily. At this step, we want to whisk it for about 5 minutes. I'm only going to whisk it for a very short time because the sound of this is quite annoying. Now, you might have seen why I'm wearing my apron. It is messy business, so do use a bigger bowl than you think you need to. And you're going to need to spend a few minutes trying to dissolve it. I'll do mine for a little bit longer. I am using a bit of show business here to cheat today, but 5 minutes you need to whisk for. Now, what we're aiming for here is to dissolve the sugar. Mine's not done yet because I can see there's still lots of granules. It's very gritty on the side of my bowl. You can even look underneath and you'll be able to see that I have some crystals settling in the bottom of my bowl. So I'm not done. You guys will keep whisking and whisking and whisking for 5 whole minutes. So put on a couple of your favorite songs and have a dance around the kitchen while you do it. Take it in turns in case your hand cramps up. And feel free to use an electric hand beater instead of a whisk like mine. Once you have completed that full 5 minutes of whisking, you can move on to the next step. I'm going to cheat, and I'm going to do it now for mine. right? Mine won't work out properly, but luckily I've got one I prepared earlier. The next step, once you have dissolved your sugar, is to add that hot gelatin mixture. Now, gelatin's amazing because when it's hot, it is a liquid, right? Hardly any impact on flavor of anything you add it to. But when it cools down, that's when it becomes a jelly. So adding my hot gelatin mixture to my cold water sugar mixture, well, you guessed it. We're going to get a physical change, right? Those proteins right now have unraveled and are wiggling around in that solution, flowing around. But when they cool down, they start to slow and get tangled up. Right now, if they're tangled, it's just a thicker, a highly viscous liquid. But when they cool down, they form that jelly cross-linking, but not bonding between proteins. So when you add your warm mixture to your cold mixture, you want to make sure you get whisking straight away. I'm ready. In it goes, and check it out, guys. You can see it's going white. Now I'll stop for a second so I can show you what's happening here. Can you guys see that's going white now? It was a clear liquid that was translucent. We could sort of see light moving through it, but now it's becoming opaque. And all of those air bubbles are getting caught in between that protein gelatin as it firms up into a gel. Let's get some more bubbles in there. We want it to double in size here. Now I can see mine's getting thicker and thicker and thicker. It's completely opaque now, but I want to see it rise even higher up the size of that bowl. Now this can take a minute, 2 minutes, right? So be patient, and you're looking to see that the volume, the space it takes up in the bowl, is about double. We'll give it a little bit longer to see if I can get there. Make it nice and glossy and thick. Now, I'm going to stop there. I've got some on my nose, right? Because I know mine's not going to work. I skipped halfway through that first step. I didn't dissolve all of the sugar. Just like making meringues, if Mum or Dad have ever tried that, right? Dissolving that sugar properly is a key to getting our mixture nice and glossy. Now, you can still see mine is aerating beautifully. As that gelatin cools down, it holds that gas in there. But I know it's not going to work. So I'm going to stop there and just explain to you that once you follow the procedure, your mixture doubles in volume. It's beautiful, thick, white and glossy, almost like whipped cream. Then you're going to pour it into a mold. Now, I recommend using silicone. If you don't have any silicone molds, whether it's an ice cube tray or a little baking tray or even cupcake trays, right, silicone ones, you can use a regular metal baking tray. Just make sure you coat it really well with baking paper and maybe a little bit of kofa or other oils to stop it from sticking. All you need to do, though, is pour it into your silicone dish and wait. Now, this is the hardest part of the whole experiment. It can take 2 or more hours for your marshmallow to set, depending on what shape you pour it into. 2 hours is ages. But plenty of time to jump on our online learning lab and maybe watch a couple of other interesting videos. Luckily enough, we don't have to wait 2 hours today because here is one I prepared earlier. Now, you can see it's the same shaped container, right? But let's have a look at what's inside. I have an absolutely beautiful little white marshmallow pie. Bring that camera down so you can see it. It's reflecting a lot of light. It's so bright. And, well, if I get a knife and I cut into it, I'm going to dust it with a little bit of icing sugar so it's a bit easy to handle. and pick it up, we have a beautiful, soft and squishy marshmallow, right? Now I'm going to bring it a bit closer so you guys can see that little sandwich of ooey, gassy goodness. Very floppy as a marshmallow should be. And, well, I haven't washed my hands recently, so I'm not going to try and eat this piece. But I can't wait to have a taste of that later on. But we shouldn't stop there. In fact, should we do another experiment with this marshmallow? You guys can coat that in sugar, leave it in a Tupperware container, airtight for a week and eat it later. But there is one other experiment that's really fun to do with marshmallows. You've probably done it before when you were camping. Toasting marshmallows. Did you guys realize that toasting marshmallows is actual serious science as well? Caramelization is one of my favorite experiments to do and something I'd love to explore with you guys later on. But to give you a sneak peek today, I brought along my little blowtorch that I use when I'm making creme brulees at home to replicate toasting our marshmallow. When something with sugar in it and fats and proteins, amino acids, like we find in our gelatin, gets heated up to the right temperature, something called the Maillard reaction occurs. This Maillard reaction is what's responsible for most deliciousness in baking. It's what makes things brown and gooey and buttery and caramelized. And my little blowtorch is going to be able to show you how it happens with our marshmallow. I'm going to stand up, bring it nice and close for you guys so you can see it, and turn on my little flame torch. This one is one specially for cooking. There we are. You can see a nice blue flame. And as I run that blue flame over my marshmallow, right, we're waiting for a change. Oh, there we are. I'm seeing some browning. That beautiful caramelization occurring. Let's flame it up again. There we have it. Beautiful, brown, gooey, melty marshmallow oozing straight off that wedge onto my tray. That Maillard reaction smells absolutely beautiful. And once I've washed my hands, I'm going to try toasting some more for myself later on. But for now, that is our make your own marshmallow experiment that I'd love for you guys to try later on. Come back up with me though, because I did mention I wanted you guys to experiment with leftovers that you haven't eaten this weekend. It's not all about making more. So let's do a little experiment to test if some store-bought marshmallows might be composed of air in the same way. Let's think about what you guys already know about air. Yeah, it's a combination of gases, right? Yeah, it's useful for breathing, definitely. It's made of particles. Very good. And those particles of air, whether it's oxygen molecules or hydrogen molecules, nitrogen molecules, or bouncing around in the space around us, are moving. The nature of a gas, right, is those particles are quite far apart, just jiving around the place, moving with lots of heat energy that allows them to vibrate and take up space, take up volume. But we can contain that gas, even if it has lots of energy in it. And our marshmallow uses gelatin protein to do it, that porous gel. So my little rabbit here, right, contains about 50% of its volume as air. Got a pink one too. These ones are delicious, right? Let's test what happens to our little bunny rabbits if we apply some energy. You might notice when you're toasting marshmallows that they actually expand as they brown, right? And that is because, as well as the Maillard reaction, caramelizing those sugars and amino acids, we have those air molecules inside that porous gel trying to stretch, trying to push their space around them larger. We don't have to toast it to do that though. We can energize, right, and heat energy to those air particles using a microwave, which I've got next to me. I'm going to pop my two beautiful little bunny rabbits. Might have to get a different plate so you can see them a bit better. Right, into that microwave and turn it on to observe firsthand what happens to those air particles when we heat them up. Bear with me while I grab another plate. No, we'll just use our yellow one because I can't find another one today. I'm going to open up my microwave, which I prepared earlier. I've got my little bunny rabbits having a little smooch, having a little kiss here on my plate. And into the microwave for about 30 seconds. Now, if you guys do this at home, make sure you watch so that your marshmallows don't explode because it can seriously happen, right? Those air particles inside that porous gelatin are bouncing around, gaining energy, pushing on all those little stretchy sugars so much, well, that they could actually explode those sugars. But more obviously, it makes our bunny rabbits huge. Look how big they are. I mean, they were this big to start with. And you can see that my bunny rabbits have doubled in size. Whereas our gelatin was easy to hold, our bunny rabbits are now very sticky and stretchy. Not only have we expanded the gas molecules, but we've also changed the composition of that sugar in there. But right now, can you see something happening? The little white bunny is shrinking back. And so is our pink bunny. They are returning to their original size. As the air particles in there cool down, they lose energy. They slow down. They take up less volume. Now, our pink one is kind of smeared down the plate, but our white one is almost back to his original size. Now, I'm going to touch them and just see how they've changed. Still sticky, still stringy, and probably still sweet and delicious. But while the change to those air particles, heating them up and cooling them down, was reversible, unfortunately, the sugar and gelatin matrix, that gel, well, it's an irreversible change. And it will not go back to the texture, nice and spongy, that it once was. Instead, you'll find they shrivel up, lose their shape almost completely, and might even become a little bit hard. So an interesting experiment you guys can do with some marshmallows if you've got any left over after the Easter break. Even try doing it with the marshmallows you make yourself. Now I'm going to put that out the way. I'm going to wash my hand down a little bit to get rid of that sticky marshmallow. And, well, have a quick shout out to some very important people today. In fact, birthday people. Before I do though, guys, I want to quickly mention if you have any questions while our chat page has been shut down today, you can jump on our Facebook page. There'll be a post about today where you can put some questions down. And my producer, Brian, will ask me some of those questions in a little while. But first, those birthday legends, we have a fair few today. Katie from Northgate. I know you got a shout out yesterday, but I wanted to say hi. Happy birthday today, legend Katie, 10. All right, Sam, 9 today. Happy birthday. Lincoln is 7. Thanks for watching, Lincoln. And, of course, well, I can't go past saying a very, very big birthday to somebody with one of the most amazing names on the planet, Jess, out there having your 7th birthday today. Happy birthday, mate. Welcome to the League of Jesses. There are a lot of us around. Now, I'm sure if Brian gets any cool questions on that Facebook page, he'll hold it up, yell them out to me in a little while, right? But I did want to just briefly move on to one of the key parts of my Easter growing up. And that, for me, I was lucky enough to have an Easter egg hunt. Now, you might think that I'm clutching at straws here, trying to make science out of, well, excuses to eat lots of sugar. And you're right. I do love eating lots of sugar and exercising to work it off. But Easter egg hunts actually has a really interesting element of science to it. And it's a problem that I've encountered year after year after year that could be the reason why I got into science. The science of melted chocolate. Now we have a quick question I'll get to first before we get onto chocolate. Was it a physical or chemical change for our marshmallow there? That's a really, really good question. Both cases, whether it was making our marshmallow from scratch or, right, heating up our marshmallows, had different things going on. Usually baking involves cooking, which involves breaking apart chemicals and making new bonds. That is a chemical reaction. Making our marshmallow today, though, was a bit different because we didn't actually form any new bonds. All we did was change the shape, the structure, right, of our gelatin. We unraveled some proteins and made them arrange in a different shape. They didn't actually bond together. There may have been some small bonds broken when they unraveled, but for the most part, gelatin does not form new bonds, so it is a physical change. Our poor bunnies. You can see now that large bunny is totally changed, right? That was mostly what we saw, that change in volume, a physical change. As our gas particles gained energy to expand and shrink back again, the chemical structure isn't any different, right? They just physically change by moving more or moving less. The sugar, though, well, the fact that it doesn't retain its original shape, there is likely chance that some of that sugar has changed its bond structure, so gone through a chemical change. And I can promise you, a Maillard reaction, that is a chemical change, right? Pretty much anything involving fire is a chemical reaction. Really good question, though. Good stuff. Google all of those, by the way. There's some really interesting science around chemical and physical change. The chocolate. We should get into it, right? Because, well, we're going a little over time, but I think for an Easter special, we can't move on without exploring chocolates. Now, I actually asked Science Steve yesterday to grab some chocolate for me. And I got in this morning and I could not find it. I called him and I said, Steve, where are the eggs? And he said, Jess, check the blue water. That didn't make sense to me, right? But sure enough, I came into the lab and I found this big jug of blue water. And in the bottom of it, well, what did I find but an egg? Check this out. Now, it's certainly not the chocolate egg I was looking for, but it appears to be one of those free-range eggs down from our local shop. But there's something very strange about it. Not only is it blue, but it's squishy. It's a little bit bouncy, but still soft on the inside. And if I'm careful with it, I move it around, I can actually see there's yolk on the inside still. So I called Steve back and I said, Steve, that is not my chocolate eggs, but what did you do? Then he told me. I sniffed it. It was obvious then. Our vinegar and food dye reaction, mixture I should say, has totally dissolved the shell of our egg. Calcium carbonate is a huge part of our eggshells, and it can be dissolved by the acid called acetic acid in our vinegar. I believe Steve told you guys to try this yourselves at home, and by now you might have seen this yourselves. Our beautiful egg has lost all of its shell and now is only held together by the incredible membranes inside that eggshell, right? Reproduction has some incredible membranes. I've learned about them recently myself. And those inside our eggs, right, are very strong indeed. So strong, you could actually even try bouncing it. But I think that's one for you to try at home, outside. I don't want to make a mess today. Now, after I discovered Steve's amazing science experiment, I went exploring further to find my chocolate eggs. I looked high, I looked low, I looked all through the lab, and I found them in Steve's office. But unfortunately, he put them near the window. So when I found my Easter eggs in Steve's office, well, their properties had changed. I think it's safe to say there's been a physical change here, where my beautiful, solid chocolate Easter eggs had melted into liquid. and totally change their shape. They re-solidified back into our very squished Easter egg shape again, back into a solid, but their shape isn't going to help me out anymore. But I thought just because they're not as beautiful as they once were, that doesn't mean our science is ruined. In fact, I think it means we can learn something even more valuable about chocolate, the science behind chocolate structure. Now, we won't spend too long on this because I'd love you guys to research it yourselves. But chocolate, amazingly, has 6 different chemical crystalline structures. That's pretty crazy. Like water, we know, those liquid water particles find themselves finding a particular shape every time when they freeze into a solid with those little boomerang shapes. Chocolate molecules, however, can come together to form a solid 6 different ways. It is a polymorphic solid. That's pretty amazing. But the sad part is only one of those 6 forms is delicious. Chocolatiers are incredibly skilled scientists. I repeat, chocolatiers are scientists because they know exactly how to encourage our chocolate to form that right crystalline structure. They use something called a nucleation site sometimes, which involves slipping a good piece of chocolate in to the liquid chocolate to help it form that right structure, using that first little seed piece as a template. Or they go through a process called tempering, which involves heating up and cooling down and heating up the chocolate just so to get it to form the right structures. And, well, when it doesn't form those structures, the results are pretty obvious. I'm going to hold up 2 different pieces of chocolate here. I want you to have a guess as to which one is the correct crystalline structure that we enjoy to eat and which one might have gone slightly wrong. In this case, which bit of chocolate had been hidden in the garden for Easter by that pesky little bunny and wasn't found in time. It was sitting out there all day, got really, really, really hot. Then, well, was found that night once it had cooled down again. I'm going to hold up 2 bits of chocolate for you. Here we go. Thinking about it. Turn them sideways. You can see there is definitely a change in their colour. Something you might have seen before with your chocolate that's not been stored properly. Can anyone have a guess as to which one is the correct polymorph of chocolate? It's easy, isn't it? This beautiful dark brown glossy finish. This one, well, has this weird white bloom going over the top of it. And it's really, really waxy and powdery, not glossy at all. If you have Easter eggs or chocolate this weekend that has heated up and cooled down again, you're probably going to see this happen yourselves. Now, it's nowhere near as delicious to eat, and you've probably got enough sugar already in your system this weekend. So why not do some science with it? Sacrifice a little bit of good chocolate, a little bit of your bloomed chocolate of the wrong crystalline structure, and do some other tests. It's not just about how it tastes, though. There are so many other tests you guys can check. You can test how it sounds when it breaks, right? Your nice glossy chocolate should snap beautifully, whereas your weird bloom chocolate will probably crumble. You can totally test how it tastes just a little bit. But one other thing you can do is test their melting point. Now, a way I like to do it is to set up an apparatus, a big container, 2 small glass dishes inside it. Make them the same size and shape to make it a fair test. I'll show you. Put my messy bunnies out the way. There we are. Where's our camera? And then the last thing you want to do, bring you down a bit further. Is our camera going to focus? We'll leave it for now. And add boiling water around them. Get mum or dad to help out with that. Before you pop 2 pieces of the same size of your chocolate in those dishes. You might get a little spoon or a stick and stir them around. And with this easy apparatus, you can test the melting points of your different chocolates. You might find the good chocolate has a different melting point to our Bloom's chocolate. You might not. You might then go on to test all the different types of chocolate you've acquired over this long weekend, right? Even into the future. When mum or dad have some chocolate in the fridge, ask them if you can do a little test with it. Dark chocolate, white chocolate, Bloom's chocolate, milk chocolate, chocolate with sprinkles in it, right? All of those additives can change the melting point, a really important property of the materials around us. Now, I could go on for ages talking about chocolate, but all of this talking about sweets makes me really hungry for morning tea. So I might leave that with you as a little experiment you guys can try at home, right? When you see something go wrong, like your chocolate blooming, seemingly destroyed, don't give up. There's always some science we can learn. Now I'll bring you guys up with me one last time. Before I get ready to go wash my hands and have a cup of tea myself, right? I do want to remind you that tomorrow we will not be running our virtual classroom, nor on Monday, because Science Steve, all of us street scientists, we've been working really hard getting our learning lab resources ready for you. So we're going to have a few days off. But rest assured that on Tuesday, Science Steve will be back, continuing on with our Easter-themed science, experimenting with eggs. Or should I say, experimenting? Hey? No, you're right. If you guys do want to join in, make sure you've got yourselves a dozen eggs, and you can experiment along with him after our session on Tuesday. Same time, same channel on our virtual classroom, 10 a.m. free lesson streaming. If you can't wait that long though, guys, please do go on our website, go onto our resources tab, click to our virtual toolbox and check out our learning lab. There are some free videos up there. You'll find this one uploaded there later today, along with my marshmallow recipe, and a whole bunch of other resources that we will be slowly releasing over the weeks. Get a subscription, guys. At the moment, we are offering 15% off all of our subscriptions. If you are more interested in buying some stuff you can do at home, guys, go through to our store. You'll find a little link to it in our offers tab where you can buy some gear to try your own science at home. Guys, thank you so much for hanging out with me today. I love my baking, I love my sweets, and I love teaching you the science of them. So I hope you've enjoyed it as much as I have today. Please enjoy making your own marshmallows at home. Please take photos of experimenting the marshmallows or chocolates you guys have around the house this week. And, well, I look forward to hanging out with you guys again very, very soon. We'll see you online, see you on Facebook, rewatch the video later on, but more importantly, have a wonderful Easter and keep on learning. I'm Jess from Street Science. We'll leave you with a little video, which I'll get my producer to pop on for you now. And, well, we'll see you next time on our Street Science virtual classroom. See you later.
We love science so much here at Street Science. We teach kids about science and we do it in a really, really cool way. We're going to be teaching them the science of fireworks. We're going to be working with liquid nitrogen, some amazing visual stuff. It looks and feels just like snow. Let's ramp things up a little bit. Who likes fireworks? I'm going to try and shoot these cups off your head. Not by using magic or anything crazy, just by using science that we can't see. Can you guys see a liquid in there? Look at that dark patch at the bottom. That's Laura's breath. Can we sneak in one more quick demo? We love science so much here at Street Science.